Okay, so the Pythagorean theorem is the only theorem for this section. We're going to apply the theorem in different ways. One of the ways to apply the theorem is to talk about finding the area of a triangle, and in this case, they're using an isosceles triangle. So remember, the area of a triangle is base times height divided by 2, or 1/2 base times height. Now, let's pretend we have a triangle. And this one's going to be an isosceles triangle, and let's say we have sides 5, 5, and the bottom side is 20. Okay? Now, here we have a base, but we don't have a height. The easiest way to find a height is to drop down an altitude. Okay? This altitude is also, because it's an isosceles triangle, going to cut the other side in half. It only happens because it's an isosceles triangle. So, the altitude is going to give us the height of the triangle. So now, if we want to find the area of the triangle, we have to find the height first, correct? Yep. Okay, so what I'm going to do is pull out one of those triangles. This side was 5. Actually, this isn't going to work. I have to change the bottom to something that will work. 6. Okay? So, why? Because it wouldn't work the way that I had written it out. Mathematically, it's not acceptable. Because this side would have been 10, and then you can't have a side. The hypotenuse has to be the longest side. So, alright, so I changed this, so now I know that, what did I say, since it is an isosceles triangle, cuts it in half. So this side's going to be what? 3. And then we're going to find out what this side is. We'll call it B. So we use the Pythagorean theorem. So what do we write? 3 squared plus b squared equals 5 squared. Now be careful, your hypotenuse is on the side that it needs to be on. Okay? It needs to be by itself. So 3 squared is 9 plus b squared equals 25. And now what do we do?
Subtract 9.
Good. So we get b squared equals 16. And then what do we do? Square root, and we get b equals what? 4. So, we could have also called this h for the height, right? Because that was our point to find the height. So once we have that, are we finished? No, it asks us to find the what? The area. So the area is going to be 1/2 times what? 6 times 4. 4 times 6 is fine too. It doesn't matter which way you put it. But the base is 6 because we're finding the area of that triangle. And then the height is 4. So that would be 12. That's correct. 1/2 times 6 is 3. Times 4 is 12. Or you could say 6 times 4 is 24. Times 1/2 is 12. And then it would be 12, whatever units this was, squared.
No, I was just going to ask if it's like units if there's no unit given.
You don't necessarily need to. You can put unit squared though. Alright. The other idea that we're talking about from this is called the Pythagorean triple. Now we actually just dealt with the Pythagorean triple. The smallest Pythagorean triple we have is 3, 5. This biggest number is always going to be the hypotenuse. The hypotenuse is always going to be the longest side of the triangle because it's across from the 90-degree angle, and the 90-degree angle is always going to be the biggest angle. So, what is a Pythagorean triple? A Pythagorean triple is 3 positive integers that satisfy the Pythagorean equation.
Does it have to be consecutive?
No. That's a good question. They won't be consecutive most of the time. So what that means is you have 3 values that are integers that happen to be able to work for a squared plus b squared plus c equals c squared. All 3 of them have to be integers. And they do not have to be consecutive. The only thing is they have to be integers, okay? So on page 435, there are some common Pythagorean triples. Three, 4, 5. And then multiples of 3, 4, 5. So, like, if you have 3, 4, and 5, well then 6, 8, and 10 is also going to work, because that's all of these times 2. All these times 3, 9, 12, and 15 is also going to work, and so on. 3x, 4x, 5x. They also give you 5, 12, and 13. That's another set. And again, if you multiply these by 2, 10, 24, 26, that'll work. If you multiply them by 3, 15, 36, 39, that would work until you had 5x, 12x, 13x. So they have another few on page 435 for you. They end up being 8x, 15x, 17x, and also 7x, 24x, 25x. But if you want to look at the actual numbers that go with them, 8, 15, 17, 7, 24, 25, you can multiply these all by 2, multiply these all by 3, and so on.